this one looks kind of crazy, but it's actually going to be a pretty easy one. We did do this one on Friday also. So if we plug 1 in, and we take the integral from 1 to 1 of anything here, as long as 1 is defined in this function, which it is, because we would have 1 over 1. So if we take the integral from 1 to 1, what are we going to get on top? 0. Since those limits are the same, we're going to get 0. And on the bottom, we would have 1 cubed minus 1, which is 0, right? So we get 0 over 0. That means that we can use L'Hopital's rule, and we can take the derivative of the top and the derivative of the bottom. What is the derivative of the integral from 1 to x of dt over t? So we want to evaluate that derivative. That's going to be the top. You guys remember what we did here? Yeah, this is the first fundamental theorem of calculus. It's kind of an important theorem. That's why they call it the fundamental theorem. This is the theorem that ties derivatives and integrals together. And basically what it says is if we take the derivative of the integral, then we get back to where we started. So we just put the x in for the t, and we get 1 over x. So in this limit here, the derivative of that integral is going to be 1 over x. And then on the bottom, what is the derivative of x cubed? 3x squared. Now, if I try putting 1 in now, what's going to happen? Can I do it now? Yeah. So on top I get 1, on the bottom I get 3. We get 1/3. Pretty complicated looking problem that turned into a fairly simple problem by knowing the fundamental theorem of calculus.